The shift method of the array type in JavaScript is quite an expensive operation, because by removing the first element of an array, it needs to reassign all other indexes. If you need to make intensive use of shift, it's worth considering implementing a queue based on a linked list, which is what we're going to do today. So we simply start with a class called queue, and of course it has a constructor where we do our basic initialization. Internally, a queue has two important properties. One is the head and the tail. Items are retrieved from the head, so that's why we take out the items. And the tail is the part of the queue where we put new items into. And of course, we need to keep track of the length, which is technically not necessary, but if we want to know how many items are in the queue or if it's empty, it's always nice to have a length property. Now we need to implement two operations. One is for adding new items to the queue, which I'll simply call push. And I use the rest operator here, which means that the function takes an arbitrary number of parameters, and all the parameters are nicely wrapped up in an array, which is here called values, which allows me to iterate over all the values which are passed to the function via the for each function. And for each value, we now have to do specific things. The first thing is we need some data structure now, because the queue is here and at this time implemented as a linked list. And therefore, we need one item object representing one node in the queue. And of course, we need to store the value at this current item. And each item needs to know the next item. So we have a property called next. And since this is already the new item being added, we have no value for the next property, which is the simple reason why we initialize it with null. And now we need to manage our head and tail. If the queue is not empty, this is actually quite easy, which means that at the current tail, we set up the next property to be our new item. And at the same time, our new item becomes the new tail. So if the queue is not empty, that's actually everything you need to do. So now we have some special cases. For instance, if the queue is empty, there is no tail. And this can only be done if we actually have a tail. And of course, what we also need to do is we need to increment the length, because we added a new item to the queue. And another thing is that we need to manage the head, because if the queue is empty, there is no head. So we now manage the tail, but the head still stays empty once the queue is not initially populated. So what we also need to check if there is no head, the first item that we push, of course, becomes the head item. So, and that's actually everything we need to do for push. Let me cross-check one thing, because what happens for the normal JavaScript array, if you push an arbitrary value, it returns the count. Yeah, exactly, it returns the count. So let's do the very same thing. We simply add one more return statement, which just return the current length. And vice versa, now we need a function that removes items from the queue, which is called shift, and it doesn't take any parameters. And now again, we need to take care of our pointers, but first and easiest thing is to retrieve the actual return value of our function, because this is the current head's value, and this is already the value which will be returning. And now most of the function will just be managing pointers, which means that once we have retrieved the current head's value, we need to forward the head one position forward, and this is done by assigning the head to the current head's next value to the head variable. And that's actually already how you do it to forward. And since we remove one item from the queue, we simply decrement the length. So now we have to again take care of edge cases, which means that after we have removed the last item from the queue, next is null. And therefore, if we have no head, we also don't have a tail anymore, which is the reason why we initialize, no, not initialize, but set tail back to null, because no head also means no tail. And now we again have to cross-check one thing, because what does shift do on an empty array? It returns undefined, so we do the very same thing here. If we have no head, we simply return undefined. And that's already it, what we need to do with shift. So let's test this stuff a little bit, which means that we initialize a new queue instance. And let's just push a few items on it, which means A, B, C. And let me quickly set a breakpoint, because we want to know what is actually happening. So we're going inside, and as you can see here, the values array contains A, B, C, which is quite nice because that's the order of the parameters which has been passed inside. And now let's see if actually our pointer handling works. So we have the item, first value is A, no next item. And now we already have the edge case because our queue is empty. So head is null, which means that our item becomes the new head. And we don't have a tail, so we don't do this here. And also our current item becomes the tail. So the first item in a queue at the beginning is always head and tail at the same time. And length is 0, and afterwards 1. Perfect. So next item, we have value B here, and of course no next item yet. And this condition is already not true anymore because we have a head, so we do not touch the head because that's the first item always. And we have a tail this time, so we need to manage our pointers such that the current tail will be pointing to the new tail, and the new item becomes the new tail. So here at this point we initialize our tail, the next property of the tail, with the new item, which has a value B and no next item, and it becomes here our new tail. And of course length now becomes 2. And this way it just goes forward because it's the very same case for the third item. And of course we're going to return 3. Perfect. Now let's do the other way around, which means that we're going to remove all those items from the queue again, which means that we use a while loop, because while there are items in the queue, and this way we're also able to test the management of the length property. And while there are items in the queue, we simply shift them off and write it on the console. So let me of course also set a breakpoint here. Remove the old one. And now let's go through it here. Perfect, because currently we have a head, which means that we do not return undefined. We get the first return value, which is A, the first item of the queue. Works also nicely. The next item is value B. Perfect, so it becomes our new head. We have one item less now, which means length becomes 2. We still have a head and the return value is A, and I expect now to be A output to the console. Perfect. So we keep this running, and now the last item is critical because we now return the last value, and we don't have a head anymore, so we also don't have a tail anymore, and works very fine. Okay, length is now 0 and the while loop is terminated. Perfect. Final test case. I want to see undefined on the console once I shift off an item that actually does not exist on the queue. So let's give this a try. So we don't have a head anymore, and we simply return undefined. Perfect, works very well.